Hello and welcome to all in this video lecture series on 8051 microcontroller. We are discussing hardware interfacing with 8051 microcontroller. In previous session we had discussion on liquid crystal display, that is LCD, the basics of LCD and the steps that are required to interface this 16 by 2 LCD with 8051 microcontroller. So, as we have seen, basically the two modes of operations that are supported by the LCD, the one is a 4-bit mode and another is a 8-bit mode here. So in this session, we are going to talk about the LCD interfacing with 8051 microcontroller in 8-bit mode. So here, as we know that in 8-bit mode, the data or command is sent in 8-bit format. To do this, all 8 bits are sent simultaneously, as whatever the either data or the command that we are going to forward to the LCD from 8051 microcontroller is there into an 8-bit format. All the 8 data lines, that is from D0 to D7 of LCD, are get engaged or are connected to 8051 microcontroller. And the logic for rest of the control pin, that is register select, RS, read or W, that is R/W bar, read or write operation, and for enable, these operations are common, means these are connected to single GPIO. Okay, so here as the data or the command is forwarded into 8-bit format, all the GPIO pins of specific port of 8051 microcontroller are engaged. And here, in order to activate the 8-bit mode for LCD, what we are going to do, we are going to make use of the command 0x38. Okay, so here it is the connection. So when we are going to talk about a simple connection for the 8-bit format, so here this D0 to D7, all these 8 pins are connected to 8051 microcontrollers, one of the port. Okay, so let us discuss a simple example. Write an embedded C program to display string DKTE to first row in LCD in 8-bit mode with these connections. Okay, so the RS pin of 8051 microcontroller, as shown over here, is connected to P2.0, R/WR is connected to P2.1, and EN is connected to P2.2. Right, so these are the control pin connections. Okay, and the data that we are going to forward from 8051 microcontroller towards this LCD, right? So that is command or data that we are going to forward, through this D0 to on the D0 to D7 data lines of LCD through this P3.0 to P3.7, right? So as here mentioned, we have to make use of the 8-bit mode. Basically, the first command that we are going to use is 0x38. Okay, so what it will do? Simple, it is going to initialize the 8-bit mode for 16 by 2 LCD. So no doubt that we are there with different n number of commands for this LCD, which we will find on the datasheet associated with this LCD. But out of this n, the most commonly we are going to follow this sequence. So the step 1 that we are going to do is what? Simple, initialize LCD. Once I am going to initialize this LCD, the second one, what we are going to do? Simple, turn on the display and blink the cursor, so that we will get idea about at which position on this 16 by 2 LCD we are there. Okay. The third one is what? We are going to support the write increment. Write increment means what? Suppose here, as discussed, we are supposed to display DKTE. Okay, DKTE, right? So how we are writing this? We are going to start from D and going to end the operation at E, right? So here we are going to start from simple this D, okay, and we are going to end at E. Okay, so here this is my leftmost letter, then we are going to move in towards this right direction. Means we are writing the alphabets of the data from left to right, and this concept is called as what? Simple your right increment operation. Okay, so once you do this right increment, then second, the last one is what? Simple, just select the position on display. So as we know that to select the proper position, either we will go with this say here the first line or to the second line on this LCD. So when I'm going to talk about the associated commands here, right? So the commands are simple and straightforward. For initialize, first of all, I'm going to send this 38H. In embedded C, we are going to write this as 0x38. To turn on and blink the cursor, we are going to make use of either 0F or 0E, right? So I will write it in the capital letters, 0E or 0F. For right increment, 06H, and for position select, if you are interested in first row, this 80H onwards, and for second row, C0H onwards, right? So let us discuss about this displaying this DKT on this LCD panel. Now before that, the most important thing, right? So what we are going to do, simple. First we have to do the port programming. So once we finish with port programming, then send the command. These are the steps that we are going to follow here. Okay, so how to send the command? Simple. The specific command, which are these as discussed right now. So 38H, this is my first command, 0FH second command, 06H third command, and say I am interested in first row first position, 80H is the fourth command here, right? So what we have to do, first send the command. So which routine we are going to follow? In that A, copy command on port pin. Copy command on say D0 to D7, right? And that too is done through the port, right? We have to send the command on these lines, that is on D0 to D7. And as these lines in our example connected to P3.0 to P3.7, so first of all we have to send this command on this port. Now the second, the most important one, we know that this RS stands for what? Register select. And the two registers are there, one is a command register, another is a data register, and for that, as first we are going to send a command, make RS is equal to 0. So the moment at which I am going to make this RS is equal to 0, the command register is selected and the data present on D0 to D7 is treated as a command there. Okay. Now the third one is what? The next thing, right? If I am going to focus on the operation, the operation is simple and straightforward corresponding to this LCD, right? We have to simple follow each and every what we call this pin here. First configure RS, then go for R/W bar, and at last EN. Okay, so as this is a output device, simple, we are going to send a data on this LCD, means nothing but what? Simple, we are going to forward we are going to write the data on LCD, and for that make this R/W bar pin is equal to 0. And at the last, in order to enable the LCD, simple make first EN1, give some delay, and make again it 0. So what will happen? One high to low transition that we are going to send this command, right? And to send the data after that, once, and this process we have to repeat for each and every what we call that command here. For example, first we are going to send the 38H, just repeat these 4 steps. After that 0F, again repeat the 4 steps, then 06, again repeat the 4 steps, and for position control, again repeat all these 4 steps here. Okay, so for that what we are going to do, this command as the separate function we are going to declare. During the programming itself we will say it, no issue, right? Then the next step is what? That is the last step. As okay, I will write this step here. What is my third step? Send the data. So what is required to send the data? The steps are almost same, right? So what will be my first step? So first of all, as here, just copy data on D0 to D7, and that too as like command done by this port here. Now this is the most important one. When RS is equal to 0, the command register is selected and the data present on D0 to D7 is treated as a command. But now as we are supposed to send the data, now make RS is equal to 1, right? So what will happen? The data register has been selected and the content present on D0 to D7 is treated as a data and it is forwarded to display. Then the rest of the things are as it is. Then again what, make this r/w bar is equal to 0, that is a routing operation, and in order to enable the LCD, make en pin 1, give some delay and again make it 0, right? So these are the simple steps that we are going to follow in order to say simple interface this LCD with 8051 microcontroller. So let us cross check this with one simple example. So here is the example. So as discussed, the RS pin of LCD is connected to P2.0. So I am going to define the P2.0 as RS, right? R/W bar of LCD is connected to P2.1. So I am going to assign a label RW to P2.1 and EN label to P2.2 here, right? So in order to introduce a delay, I am defining one function, that is a delay function. To send command, one function, that is a command, LCD command, and to send a data, this LCD data. So by calling this LCD command function, we are going to send a command to LCD, and by calling this LCD data function, I am going to send the data to the LCD. And this is this function LCD init, this function I am declaring in order to initialize the LCD. Okay, right? So let us now cross check about the next operation. So as the data we are going to forward from microcontroller towards LCD. So what will happen? Because of that, whatever the port pin that we are utilizing, all these port pins are going to work as an output. And because of that, the P3 is equal to 0x00, the P3 is configured as output, and the P2 is equal to 0x00. These two is configured as an output. Then I am going to initialize this LCD. So what we are going to do in LCD initialization, I am going to send all the commands here. So the first command that we are going to send is a 38H. So what will happen? The moment at which I am going to call this LCD command function, right? My function jumps to this function, that is to LCD command, right? Then what is that? Say it is this 38H values get assigned to variable X. So as discussed in a steps, first I am going to copy the command on data line. So as the data lines of LCD are connected to port P3, the value of X, that is 38H, is now assigned to this P3, right? Then I am going to make RS is equal to 0. So what will happen? The command register is selected and the content present on P3, that is nothing but the content right now which are present on the data lines of LCD, are treated as a command. Then enable the write operation, that we are going to display the content, and then I am going to make EN as a 1. So just try to get this. Here what we did, simple, I am going to make P2 is equal to 0, 0. So by default the P2.2 is 0, means the status of this EN pin is now 0, right? Then when I am going to make it 1, it is going to change from 0 to 1. Then I am introducing some delay, right? And after this delay again I am making it 0. So what will happen? 0, 1 and 0 means one high to low pulse, that means one single spike is given which is going to enable this LCD, right? So in this way the first, that is 38H, this command I am forwarding, right? After that, after some delay, the next means I am going to initialize the LCD, then I am going to turn on the LCD with cursor blink. So here I am there with a 0x0f. Then just a right increment, and to select the first position I am going to introduce this 0x80H, this command. So in this way, whatever the required commands are there, these commands I am going to send with the help of this LCD init function, right? So once I do this, the next thing is what? Now I have to send a data. So which data is there? Say DKTE. This data I am supposed to transfer. So first D alphabet, as it is an alphabet, I am going to put that in a single inverted comma. I am going to first send this D, right? So now the D, it is here the LCD data function I am calling. So now it is going to execute this function, right? So first the value of Y is what? D, right? So here the alphabet D is forwarded to the data lines of LCD, and now I am going to make here RS is equal to 1. Just try to get this. the routine which is there to execute the command, right? For that res is made 0. However, here res is 1. So the moment at which the res is 1, the data register is selected and the content present on data lines is treated as a data and forwarded for display purpose, right? Then this rw is equal to 0, enable write operation and enable this LCD. So the first, this D alphabet I am going to transfer, then some delay, again K some delay, T some delay and again E, right? So in this way I am going to execute the code. So let us cross check this with simple execution. So as discussed, the P2.0 here is connected to RS pin, P2.1 connected to R/W bar and P2.2 is to enable, and then the port P3 is connected to the data lines of LCD, right? So now I am going to just execute the code. So the moment at which I am going to run the code, in accordance with that I am going to get this as a output. So here we have selected the ATH, and because of that the code is going to start, or the D is get displayed at first row first position. Okay, so let us do some minor corrections here, right? Correction in the sense what, when we go on through the commands associated with an LCD, right? So you may find the explanation for 0F or 0E. The explanation is little bit the same. What is that? Display on cursor blink. But what is its exact effect? So when I'm going to focus here, just focus on this cursor. The cursor, I will say here it is vertically blinking, right? So now I'm going to put the command as 0E, right? So just save this and again go for the execution. Right, so I'm going to halt the execution. Let me check the hex file. Right, the hex file is okay, and now just again re-execute it. Right, so just focus now. Here the style in which the cursor is blinking. Right, for 0F it is vertical, whereas for 0E it's simple horizontal. Right, as like this here. Okay, now here if I'm going to change its position in the sense, instead of 80, suppose I'm going to give here as a 85, what will happen? Just cross check this. Simple, the first row, and now the content will be displayed at 6th position. Earlier it was present at first row first position, and now it is get switched to first row 6th position. In this way, suppose I am going to write here as a 0C0. So let us cross check what will happen. Okay, so I'm going to halt it, again run it. Now my displays get changed to second row here, and say here C0 instead of 80, if I am writing C0, over here, right? So in this way, simply by controlling the commands, we can change the position of letters on the LCD, right? So this is one way by which what we did. Simple, I am going to say transfer here each and every alphabet individually. Instead, there is one more way, right? So what is that? I am going to define here, say unsigned character T is equal to T of say 4 is equal to DKTE, right? So instead of transferring each and every letter, what I am going to do, I am going to define this entire string as one of the and I, and now here for I is equal to 0, I should be less than 4, and then this I plus plus, right? And after that here LCD T of I, right? And just delete the rest of the code here, right? So in this way also we will go for execution of what we call that the code here. The code length is get optimized automatically, right? So initially I is equal to 0, so T of 0 means D first we are going to transfer, then T of 1 that is K, then T of 2 that is T, and then T of 3 that is E. So in this way also we can go for execution of the simple program. So let us cross check whether it is worked. Yes, right? So I am getting this DKTE here. Okay, so this is a simple way by which we are going to interface the 16:2 LCD with 8051 microcontroller. See, again, okay, so we will do in a both way in the sense, so I will say this as a R. Suppose the first microcontroller, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. Total 15 alphabets are there with me, right? So I want to display DKT to first row and microcontroller to second row. So let us cross check that how to do the same. So only one minor change is required here. So what is that? This routine is to display the DKT. So I will do one slight correction in the code. Instead of defining this as a function, let us write the code in a main function itself, so that it could be better for us for understanding. So I'm going to send these commands. Okay, so the C0, what I want to do, I want to display the DKT at middle, suppose, right, at the first row, and after that say I want to display the second. What is that? So microcontroller. So here this I'm going to display from C0. Okay, and here it should be what, R, and now total 15 characters are there, right? So I did these changes, right, over here. So what we did, simple. When I'm going to execute this 85H, the first line is get initialized. So at first line I'm going to display the first, that is T array. What is my T array? It's a DKT, right? And then the R for array R, that is for string R, I can say, right? So total 15 characters are there. This I want to display to the second line. So again I'm going to execute a command that will display the content at second line. Okay, so let us cross check this. Okay, so let me update the code. Where is it? Okay, let's see. Okay, I'm having some error. So what is that? Unsigned character R microcontroller string out of bound. Okay, sorry, this should be 15 because total 15 characters are there with us. So let's so I'm getting this DKT microcontroller in this way.